Now let us see query processing and MongoDB basics. Query processing. Query processing is the process of retrieving data from a database using a query. Normally we are using query for retrieving the information. But query processing, when we started using, means when a user submit a query such as an SQL statement, the database system must determine the most efficient way to retrieve the requested data. What data they are requested, based on the data it will do the process and it will give the result. The DBMS performs several internal operations before returning the result. Yes, obviously, the database management system, why we are maintaining means because of that it will do lot of internal operations before returning the result to the users or customers. These operations ensures that the query is executed efficiently and quickly. If that query is executed efficiently and quickly means if the user have getting the information very fast or fraction of second, it is called the efficient processed query processing concept. Query processing is important because database may contain millions of records and searching through all records directly would be very slow. Suppose if we have millions of record means when we search some particular information it take lot of time physically, but when we do the query processing means we will get the informations very fast. So that's the reason we are using the query processing. Therefore the database uses query optimization technique. So if we implemented the query optimization technique and indexing method to reduce the amount of data that needs to be processed. Let us take an example. Select star from student where age greater than 20. The DBMS analyzes this query and finds the best way to retrieve the matching records. Here, let's see some diagrammatic representation for easy to understand how that query processing was running. Suppose if the customer or user running the query, it will parser, then it will translate, then optimizing the concept, then execution plan will be taken place, then evaluation will be considered, then the database it will start its search and give the result. So for the centralized process of activities, data dictionary we will maintain. Based on the data dictionary only, parser and optimizer concept will be implemented. See, steps in query processing. Query processing typically involves three main steps. One is parsing, optimization, and execution. Parsing means during parsing, the DBMS check whether the query syntax is correct. The user typed the right syntax or not, it will be verified here. It converts the SQL query into internal representation called a query tree. If the query contains a syntax error, the system reports them to the user. Your typing syntax is not right, so you have to modify and type it correctly. So for that reason, we are using that parser. Then optimization. In this step, DBMS determines the most efficient execution plan for the query. Here, the customer created the query. First, we will check the query is right or not. If the query is right means, then we will come to the optimization concept. In that optimization, there may be multiple way to retrieve the same data. Yes, we have a different type of approach. It is possible to retrieve the same data, but the optimizer will suggest that which way it is the right one, or it may be executed in the which way is the right way to execute the query in very fast. So maybe multiple way to retrieve the same data, so the optimizer chooses the method that requires the least time and resources. The system will need to use the least time and resource, then it will give the result to the user. So that optimization concept will be implemented here. Execution. The query execution engine performs the operation specified in the execution plan and retrieves the requested data from the database. So for this three type of process, we will implement a different type of algorithms. Selection algorithms are used to find records that satisfy the given condition. First, we will do linear search, then binary search, and index scan. In the linear search, we already know that the system scans each record sequentially until the desired record is found. This method is simple but inefficient for large database. So it is simple but it is inefficient to for a large database case. Binary search is used when data is stored in a sorted order. The algorithm repeatedly divides the data set into two halves until the desired record is found. This significantly reduces the search time. Yes, we have 50 records means it will be split into 25 records and 25 records. In the first bucket, 25 records we have means in that 25 records, suppose if I am searching one person, Google or whether in the 25 records it will be coming or not, it will search. And if it is come means it will give the result. Suppose we have another bucket, same 25 students or employees there means there also some Google R is there means then we will have to collide both things and we will find the right solution for the users. Then index scan uses an index structure such as a B tree or B plus tree to locate records quickly. Instead of scanning the entire table, the database directly accesses the required records and using the index concept. So we have a different type of sorting algorithm. In the data structure itself, we have an idea, different type of sorting algorithms, that is merge sort, quick sort, and external sorting. Merge sorts divides the data into smaller parts, sorts each part, and then merges them together. It is efficient and commonly used for large data set. Quick sort selects the pivot element and partitions the data into two groups, elements smaller than the pivot and elements larger than the pivot. It is one of the fastest sorting algorithm for n-memory sorting. Then external sorting. External sorting is used when the data set is too large to fit into memory. The data is sorted in smaller chunks and then merged together using the disk storage. Then we have MongoDB for a NoSQL database designed to store large amount of data efficiently. Unlike traditional relational database, MongoDB stores data in documents instead of tables. These documents are stored in a format similar to JSON JavaScript object notation documents, are grouped into collections which are similar to tables in relational database. MongoDB is widely used in modern applications because it provides high performance, scalability, and flexibility. I think in this session we will try to understand how query optimization technique was involved, what are all the components involved in that query optimization techniques, and the different type of sortings, and how it is implemented in the database management concept, especially in the data structure and database management, how they are interrelated, how they are working in real life concept. After that, we are discussing about introduction about MongoDB, why we are using the MongoDB. Instead of traditional method, we have started using the MongoDB in simplest concept of approach for easy to retrieve the information based on the JavaScript object notation concept. I hope it may be useful to understand the MongoDB concept also. Thank you very much for patient listening.